Hello friends, welcome to Engineering at Movement channel. We studied about density, why density is important in engineering, how to calculate density in a simple way, and how density affects mechanical properties of material, and how physical phenomena are related to density. In this lecture, we will go into details of density calculation by experiment. And the problem arises in density calculation when we have to calculate the volume of irregular shape. For regular shape like cuboid, etc., we can easily calculate their volume. And when we are able to calculate the volume of a material, then we can calculate its weight by weighing machine and get the density. But for any irregular shape material, volume calculation is very complicated and it's near to impossible using some physical means. So it becomes very difficult to get its density. So in this lecture, I'll tell you how to calculate volume of that material and get its density. Uh, so be connected to Engineering at Movement channel. Friends, for density calculation, we will be classifying material into two categories. First category is material heavier than water, and second category is materials lighter than water. For material heavier than water, we will put the material in water and water will get dispersed, and the dispersed volume will be the volume of material according to Archimedes principle. But for materials lighter than water, we'll tell it later. So first of all, we'll get into details for density calculation of materials heavier than water. Step 1 is, friend, we have to get a cut piece from the material of a small weight, and we'll get the weight of that cut piece using weighing machine in units of gram. Then we'll take a beaker and put some water in that beaker, and we'll note the initial volume of water. Here it is 60 ml. Then we'll put that cut piece into this beaker full of water, and we'll get the final volume, and we'll note that. According to Archimedes principle, volume of material is final volume minus initial volume, and in this example it is 80 minus 60 is equal to 20 ml. Now density is equal to weight upon volume. We had got the weight from weighing machine, and volume we have calculated here, so we can calculate density easily. Now for material lighter than water, the material will float on water. If we will put that material in water, then what we have to do, I will explain it just after 1 minute. First of all, we have to cut a piece from that material and weight it on a weighing machine. Then we'll take the beaker and we'll fill the beaker with some amount of water, and we'll note the volume of that water. After that, we'll put a stone in the beaker filled with water, and we'll note the volume of water plus stone. And in the third step, we'll take the stone out of the beaker, and we'll tie the cut piece with stone using a thread, and we'll put this in the beaker, and we'll note the volume of water plus stone plus material. Here it is 100 ml. So lighter material will sink in the water, and this is the trick. Now volume of material will be volume of water plus material plus stone minus volume of water plus stone. This is also from Archimedes principle. In this example, it is 100 minus 80 ml is equal to 20 ml. So density is equal to weight upon volume, and we'll get the density here. So friend, this method is very useful. First of all, you can calculate volume of a irregular shape material and get the density. We have not to find volume of the whole part, we have to find volume of a cut piece, and we will get the density by weight upon volume, because the motive is to get the density of that part. And secondly, you can get density of a lighter material also. So this method is widely accepted in industry and it is very useful. I hope friends you have all liked my lecture, and at Engineering and Movement channel we will be bringing more lecture like these. Please like and share our videos and subscribe our channel. Thank you.